Hello! Welcome to the next video in my build log series for my virtual reality motorized shoes. I want to build shoes that allow you to walk and stay in the same place so that you can walk infinitely in the virtual world in a video game while staying in the same spot in the real world. In the last video, I tested out having two of these shoes. I built two of them and strapped in and discovered several issues with the design. And I encourage you to look at that video because I'm going to be referencing that video a lot in this one. So I took everything I learned from this prototype and then I made a new design that I think solves pretty much all the problems with this prototype. And I'm going to go over that new design right now. So here's the new design. It's similar to the other prototype that I showed in pretty much all my videos in this series so far. It uses omnidirectional wheels. These are the omnidirectional wheels down here on the bottom. But instead of using two large omnidirectional wheels, it uses many smaller ones. So it uses rows of omnidirectional wheels, as you can see. Each of these little guys here, they're a bearing with a TPU flexible filament, a TPU tire around them, and they enable the omnidirectional motion. So the way that this thing is powered is there are two motors in here. So if I get rid of the cover for a second, and let's hide the battery as well. I'm at the Arduino and battery. It's pretty much all of the covers and electronics. You can see there are two motors here. They have sprockets on them, and then these surfaces here are just the chains, the roller chains that I'm going to be using to connect the motors down to the omnidirectional wheels. And then for the Y direction, see here the Y direction, the motor powers these wheels in the middle. So when the motor turns, it turns these wheels in the Y direction, and it'll make the shoe move in the Y direction. And then the other Omni wheels, since they have all these little small wheels here, they'll roll along just fine without much friction. That's basically how an omnidirectional wheel works. So the one motor is for the Y direction, one motor is for the X direction. The X direction powers these two sets of wheels back here. And then I have two idlers in the front that just roll along. They're there so that the shoe is stable, so that if you lean forward, these wheels will support your weight. Okay, so it's a pretty similar design to the last one, just using a lot more omnidirectional wheels. But how does it solve the problems from the last design? So the last design, and again I encourage you to watch the last video because I went over the problems, there was the leaning problem, where if you lean, I'll actually open the other design, if you lean away from the omnidirectional wheels that are in here, the two big ones here, it takes less weight off the wheels. The wheels don't have as much weight pushing them into the ground, so they might skid along the ground and not actually move your foot. So the problem is your foot is right here, and all your weight is going directly, the force from your weight is going directly below. But in this design, it has to kind of be transferred along the platform here over to the side so that your weight also pushes these wheels down into the ground. But it didn't really work out super well. Most of the weight is being supported by these ball transfers, not by the omnidirectional wheels here over to the side. And as I explained in the last video, I can't just shorten these ball transfers to kind of I can't just shorten these ball transfers so that the whole thing would slant down a bit and put more pressure on these wheels, because then it causes a problem where the whole shoe just kind of rocks like this as it moves. But this new design does not have that problem because there's no need to transfer the weight from the person's foot over along a horizontal plane over to the side. The wheels are directly below the user's foot, so they will be supporting the user's entire weight. They will always be pushed into the ground under the user's weight. So there shouldn't be any problem if you lean in one direction that the wheels are at that point not supporting as much weight. They should always be supporting about the same amount of weight. At least the wheels that are directly under the person's foot. These on the side are just for stability, not really to support the weight. Okay. The next problem was the pivot problem. That was the problem where again, your foot is right here, and let's say all your weight is centered around your heel, but the two wheels are off to the side. So if all your weight is right here, but the wheel is over here, when the wheel turns up, it wants to rotate around the weight. Okay, so that's a problem that I knew was going to have. I knew it would happen, but it just became much worse. It was much worse than I thought it would be once I put two shoes on. A lot of these problems I knew they would happen to an extent, but I thought they would happen to a lesser extent than they did. Okay, so and then the solution I thought of for this design was the wheel in the front here. If the shoe is supposed to go forward and back like this, if it starts curving off to, say, the left here, then the wheel in the front would start rotating right to counteract that. But with the new design, it does not have that problem because, again, the wheels are directly below the user's foot. Since the wheels aren't off to the side, it shouldn't try to rotate around around the user's heel. Okay, so no problem there. And then this design does not use ball transfers. And that's really good because if you saw the last video, it marked up my floor. The ball transfers marked up my floor. So that wasn't good. And then they're kind of noisy too. And they just caused more instability in the shoe because I keep switching back and forth between the new and the old design. So with this design, since half of the shoe was just free to move, it made it harder for these wheels to keep the shoe in one specific direction. While I was wearing these things, these ball transfers made the shoe want to rotate around and slide around much more, and it makes it harder on these wheels to hold it in place. But with the new design, pretty much all the wheels, almost all the wheels, are going to be held in place by the motor. And the wheels expand the entire bottom of the shoe. So all across the bottom of the shoe, the wheels will be held in place by the motor so that the shoe does not rotate in a direction that it's not supposed to. The wheels that aren't held in place are these in the front. So that could be a problem. I think since most of the platform is covered by wheels that can be held in place by the motors, maybe it doesn't matter too much that these are idlers, but I was thinking that maybe I would take away this long idler here and then extend these omnidirectional wheels here, like the row of them, extend them out like this so that they cover, like they take the place of this idler, but then they can be held in place by the motor too. So in that case, an even larger area will be covered by wheels that can be directly stopped by the motor. Then it's just this idler out here that is free to move. Okay, so that might be something. That's probably something that I'm going to do. And then the the next thing, well, I mentioned it, that the ball transfers left marks. I don't think this will leave marks because each of these small wheels here is it's a bearing with a tire on it, and that tire is made of TPU. TPU is a flexible filament. It's sort of like rubber, and since it's flexible, it shouldn't mark up the floor. It's not super hard like those ball transfer wheels were. Okay, I'm still probably going to get a like a thin thing of carpet to to do these on, or some sort of platform, maybe. But it's probably not needed. We'll see. I'll do some testing with that. Maybe I'll get a big 4x4 piece of wood and use these on those, and then see if it marks up the wood. Okay. Another another advantage to this design is that it uses smaller wheels. The other design used big 3 or 3.5 inch diameter wheels, which means that the motor had to work harder to turn those wheels. It had to provide more torque to turn those wheels. And motors that provide more torque are generally more expensive and bigger. With this design, the wheels are a third of the size, so they will require less torque. More speed, yes, but that getting more speed out of motors is a lot easier than getting more torque out of them, unless you gear it. So I think that I'll be able to eventually use cheaper motors. I'm still going to use the motors that I'm using now because I don't want the power that the motors can output to be a problem at this point. I want to use oversized parts, overpowered parts to make sure that this thing, to make sure there's no problems with the structure. Then I can, when I make sure that the design is good, I can experiment around with motors that are less powerful, maybe smaller. Because then if the shoes stop working at that point, I know it's the motors and it's not the design itself. Okay. Another thing with the gearing, there is room here, I think, to do some gear trains. So I got, another advantage is this thing is smaller than the other shoe. It's, and I might, while I'm editing, I might throw in of what the shoe looks like. So this is what the shoes look like. You can see I'm wearing them and how big they are. Here's what the shoe looks like from another angle. Closer up, you can see how big it is. This current design, but this thing over here is really big. For the new design, it's smaller. But and even though it's smaller, there's still room here to add some things in. So I could possibly, if I want, add some gearing in here to gear down the motors even further, so that they have to provide even less torque, more speed but less torque. That's something that I can experiment around with, and this design just has that advantage. Okay. Then the next thing is, I noticed, I think the other design could have done this too, but this design could be a little smaller. You see this part here, where the short idler here is below. You could just slice that off, or you could just slice that and make the binding a little shorter. For somebody who has a shorter foot, you could do that. So since this design is smaller and it can actually be shorter, it could support a child's foot, or a woman's foot more easily, because this binding is designed for about my size. I'm about a size 10.5, so it's going to be a bit big for a lot of people. But with this design, you could shorten the shoe itself up a bit to make it better, or you could make the shoe longer. If I make this part here detachable, so the part of the platform here that the idler is under, I could make it so that it's detachable, so that if this isn't long enough, you could take it off and then have a longer one and then slide that on, so that it could also support people with longer feet as well. So I think that could be a really good thing to make it so that the shoe could handle people with all sorts of different foot sizes. And then the last advantage, last good thing I see about this design is that it'll be easier to print. These covers, which, whoop, I made the binding go away. These, the covering over the electronics and the motors here, that can be printed in a few parts. The box down here, so actually I will hide everything again. The box that I have labeled here, that can be all printed except for the top here. So the top will go away. This can all be printed as one piece on my Perusa printers. It's small enough to fit all on the bed as one piece, so it will make it a lot easier to print. I don't have to screw a bunch of sidings on like I did with the other design. The other design had like 6 pieces to put together to form the siding. This just, it's the one piece here, and then this top piece just goes on top. All of these things here are for sliding zip ties through to tie down the wires. And then this piece here goes over all the wires and the Arduino that sits here. But this can be printed as one piece as well. So it's like 3 pieces, and that's a lot easier to manage, and they're smaller pieces. Then it's better than the other design. And these wheels, these little omni wheels, are easier to put together than the wheels from the other design. I actually have the wheels here, and you just screw. It's just 2 parts. The white parts here. It's 2 parts that screw together, and then once you have one omni wheel in, it kind of you can screw the next one to it, and then screw the next one to it, and they just form a chain. So you can make it as long as you want. They're easier to put together. They're faster to print. So this whole thing is just easier to make. It's easy. It's faster and easier to print too. Okay. So those are all the advantages I see with this design over the previous design. Now the disadvantages that I see, there's 2 of them. One is that the shoe is higher off the ground than the other one. So these wheels add a bit of height. I'll go back to the previous design again, and you can see that the previous design, it is lower to the ground. It's lower to the ground than the new one. But the new one is only, I think, about 2 inches off the ground. So the top of the platform here is at around 2 inches. Here we can check. So I don't think it's that bad. Okay, so 1 3/4 inches, and then you add the height for the binding. So your shoe, the bottom of your shoe will be right around 2 inches. So I don't think it's that bad. And I actually extended the platform out past the edge of the binding a little bit so that these wheels here can add more stability to the shoe and keep you from tipping, keep the shoe from tipping over. So I don't think that's going to really be a problem. And then the other the other thing that could become a problem is the rod that runs through these. There's a rod that runs through these to support everything. It's only 3 millimeters in diameter, so it's pretty small, and I'm wondering, will it be able to handle it? I think it will, because the rod is pretty much surrounded by this plastic the whole way through, and if you can see, there's 3 bolts in each one of these omni wheels that's also helping to support the shaft in the middle as well. And then there's multiple shafts. So if it was just one of these shafts supporting all the way, then yeah, I'd be really worried. But you got but you got this shaft, and then all these shafts and these shafts. They're all working together to support the user's weight. So I think with all of them, that it might not, it shouldn't be an issue. But we'll see. So that's the design, and those are all the things. Those are all the reasons I think it'll work and that it's better. And those are some of the things that I'm worried about. If and that's it. So if you liked the video, leave a like. If you want to see more, subscribe. If you have any suggestions or comments about the new design, let me know. And that's it. So, till next time, thanks.